I'm Rick from Rick Jo's Photography. Welcome to Fun with Photography. Today's lesson 2, we are going to look at apertures. In this diagram here, it shows aperture settings f1.4, which is a smaller number, up to f8, which is a larger number. The larger the number, the smaller the hole. The smaller the number, the bigger the hole. In the next photo, you can see this lens here is almost wide open. This is a fixed aperture of 1.8. And down below here we have a smaller opening, which is probably around about the f16, f22 mark. The aperture stop of a photographic lens can be adjusted to control the amount of light reaching the image sensor. In combination with shutter speed, the aperture will regulate the image sensor's degree of exposure to light. Typically, a fast shutter will require a larger aperture to ensure sufficient light exposure, and a slower shutter will require a smaller aperture to avoid excessive exposure. Now here we have a crude demonstration. Each one of these little funnels here, I don't know if you can see in there, that one has a small hole. This one here has a medium-sized hole. And this one here has a fairly large hole. We'll say that one there is f2.8. It's a wide aperture, a medium-sized aperture, and that's a small aperture. These glasses of water here is going to be the flow of light. So we'll start with the small aperture, and we'll pour the water in there. And that took a little while for the water to get in there. So if you classify this water as flow of light, with the smaller aperture, that flow of light going into your sensor takes a lot longer, so you need a longer shutter speed with a smaller aperture. With a medium-sized aperture, that water went in there a lot faster, so the flow of light is a lot faster with a medium-sized aperture. And with a very large opening, wide open, we pour that water in, and that water goes in very quickly, which means the flow of light into a wide aperture. You need a very fast shutter speed for all of these to be exactly the same exposure. Now, that water there went in fairly fast on the wide open one, and I just said the word fast. A lot of photographers refer to a lens that has a fixed wide aperture through the zoom lens or a prime lens as a fast lens, and that demonstrates why. So as that demonstration shows, the flow of light into a wide aperture is a lot quicker, so your shutter speed is a lot quicker for a wide open, and for a narrow, small aperture, your shutter speed is a lot longer. What that does now is each one of these apertures have the same exposure at that shutter speed. But what that does now is affect your depth of field, and that's what we're going to look at next. Depth of field. In this photograph here, you can see that one line here is the only part that's in focus. Your depth of field comes from about here to the back of the line there. That's a very narrow depth of field. Everything in front and behind that is out of focus. In the next diagram, you have the camera. This camera is probably set on about f2.8, somewhere to that effect, and your depth of field is very narrow. So this point here is the part that's in focus. Anything before or past this point is out of focus. So here you have a very narrow depth of field. Next diagram shows this flower. The whole flower, all the flowers here are all in focus. The background is reasonably still visible. A little bit out of focus, but that's a fairly mid-range aperture, and it does show detail in the back as well as all the front. This diagram shows the same photo but with a wide open aperture, probably about 1.8, and you can see the depth of field here is a lot narrower. This part of the flower is in focus. Even these flowers in the front here are just slightly out of focus, so the depth of field is very narrow and everything out in the background is just totally blown out of focus. This photograph here shows depth of field in the extremes. This circuit board, this part here, compared to this part here, is about 10 mil difference. This is about 10 mil higher than this part here. This was taken at depth of 22, so a very small aperture, so everything is in focus. The next one here is f14, and you can see here that c15 is just starting to go a little bit out of focus. And the last one here is f5, and you can see that that's completely blown out. The depth of field here is just millimeters. It is very, very narrow. So that is how changing your aperture size affects your depth of field. In photography, especially in portrait, you would want a very narrow depth of field, blow out the background, so you can focus everything on your subject, which is the person being photographed, in a portrait style. And if you're doing landscape photography, you'd probably want mid-range to a higher f-stop. So you want everything in focus. You want that depth of field to be a lot greater, so you can get everything in front right to the back mountains or whatever the case may be, all in focus. Well, I hope you enjoyed that video. Please remember to like and subscribe, and check out my website at rickjsnowphoto.com. Next week we'll be looking at exposure and shutter speeds. Until then, see you later. Bye.